Okay, today I'm going to talk about a topic in P1 about ultrasound and infrasound. Now, first of all, we need to know a little bit about sound waves. I've drawn two different sound waves here. So just to recap, sound waves are longitudinal waves. This means that the direction of the vibrations is the same direction that the wave is traveling. So they're in the same direction. Now, what we can see here is we can actually see there's different compressions in either wave. So on this top wave, we can measure the wavelength, which is the distance between these different compressions. So the wavelength for the top one is quite short, whereas the wavelength for the bottom one is quite long. Now, the shorter the wavelength, the higher the frequency. Now, what ultrasound actually is sound that cannot be heard. The frequency is too high to be detected by the human ear. So it's any frequency above 20,000 hertz. Hertz is just the units for frequency. So infrasound is like the opposite. Its wavelength is very long, meaning it has a very low frequency. It's anything which is below 20 hertz. So again, we can't hear this sound because it's too low a frequency. So we can actually use infrasound and ultrasound for different things. You could use ultrasound for baby scans and also for sonar in submarines that we're going to look at in a minute. And infrasound is used by elephants to communicate with other members of their herd, because basically this one can travel over long distances and be diffracted around objects easily. So this one could be used by elephants. Also, meteor strikes and volcanic eruptions produce infrasound, which can be used to detect them really far away. So that's the basics of infrasound and ultrasound. So we're going to quickly now have a look at how ultrasound can be used in submarines as sonar. So what we have right here is, you'll see my beautiful drawings. Underneath the sea, we could have a submarine. Now, this submarine can use sonar to try and detect how far away different objects are. So this is how it works. It emits ultrasound, which travels down to the bottom of the seabed, the seafloor. Due to the high frequency, a lot of this sound is reflected back and can then be detected by the submarine. So this here is my beautiful submarine. Now, we could actually use an equation that we should have seen before to find out exactly how far away this the sea floor is. By doing this equation, speed equals distance over time. Now, we know, or rather we'll be given this in an exam, we do not need to know to remember this. The speed of sound in seawater is 1,520 meters per second. So that's just how fast this ultrasound is traveling through the water. So let's say in this particular instance, it took 10 seconds for the ultrasound to hit the seafloor and reflect back up and be detected by the submarine. So this is what we need to do. Because we're looking to try and find the distance to the seafloor, we cover up our distance. So we now have speed times time. So we're going to do 1,520 multiplied by 10, which gives us 15,200 meters. Now, this isn't our final answer, because what that's told us is the distance all the way from the submarine to the sea floor, and then all the way from the sea floor back up to the submarine. So all that we need to do now is we just need to divide that answer by 2 to find the distance just to the sea floor. So we're doing 15,200 meters, because that was the distance from here back up again, divided by 2, and the answer is 7,600 metres. So that is one very important use of ultrasound. Thank you.